now. I'm gonna make sure I'm streaming.
Me too. 1 sec. I wonder if my audio is coming in or not. Nice. Okay, yep. And then your input capture. Okay, yeah, all right. We should be good to go. Sweet.
Okay, sweet. So for today's AI in action, I'm going to be presenting the lessons and mechanics and basically the general takeaways I've had in developing the OpenGPTs platform, which is a GitHub repository that is intended to be a clone of the GitHub repository intended to be a clone of the GPT store. So it's this, and I posted that on the on AI in action. But for the sake of this presentation, there's a couple preliminaries that I need to get out of the way. One, I had like 6 hours of sleep, so I don't know. I'm not in full capacity, but I'll do my best. So if I say something that's totally whack, feel free to check me. Another thing is I'm gonna try to keep things open ended. I'm not gonna go too far into the details. If you guys want to discuss the details, you're welcome to ask questions or um, just message me afterwards. And yeah, so those are the two things I wanted to cover, and let's get into it. So let's begin with some definitions. Wait, first thing, is the stream good? Uh,
I can see it, yes.
Great,
I'm all good, video and audio. Looks like
awesome.
we're good in the chat.
All right, great. Okay, so GPT. What is a GPT? We're just gonna assume that you guys are not familiar with it, even though I'm pretty sure you all are. So how does OpenAI define it? A GPT is a custom version of ChatGPT, a conversational LLM, instruction tuned LLM that combines instructions, extra knowledge, and a combination of skills. And in the case of the what's actually deployed via OpenAI, these skills go range from web browsing, and we can see them here: web browsing, DALI, code interpreter, and data analysis. And yeah, so those are the quote unquote skills that they're referring to. The extra knowledge is just files you can pass in, and instructions, well, LLM instructions that are static throughout the course of a conversation. And then you have the GPT store, which is just a store consisting of GPTs. Um, then the assistance API system. So this is something that I do need to mention because it is very closely tied to GPTs in the sense that the assistance API as a system is basically 95% of what a GPTs of what GPTs are, with the exception that the GPT contains a UI, as you can see here, and the Assistance API is primarily an SDK. So that is one difference, and then there is another difference which we'll get into later. But for all intents and purposes, you can think of the Assistance API as the underlying SDK for a GPT. So common use cases for, well, at least not common, Sebastian's use cases for GPTs, just to keep things subjective. When I use it, is for repetitive tasks. Like if I know I'm gonna be doing something that requires repetition, and I don't want to be constantly reminding over the course of a conversation, hey, I want you to respond in this way, and perhaps in the future I make a new conversation, then I gotta like import all the instructions and all the lessons drawn from the previous conversation over to the new conversation. So that can be a hassle. Alternatively, you can just use the GPT to create that static instruction, and that is carried over for throughout all your chats. Another reason why I use it is for fast iteration. And this is particularly pertains to GPTs and also to some degree the Assistance API. In order to iterate with GPT, in order to iterate through a GPT, you basically just need to modify this form, this like HTML form on the left side, and the changes are deployed immediately. So that's another reason, and another reason why you want to use a GPT over creating like your this is probably an unfair comparison, but instead of using like just general software, deterministic software, is if you want dynamic input. If you don't know exactly what the input is going to be from the user, which is generally the case with natural language, natural language LLMs, then a GPT will be okay. So sorry to dial it back. So why did I write dynamic input here? A GPT kind of standardizes how a chatbot should behave, right? And if you're in the process of standardizing, you might get to a point like if you look at it through an extreme, you're you could like completely standardize the process and you're gonna have like completely deterministic, discrete inputs, right? Well, a GPT is that middle ground. A GPT is a middle ground where you can have like that dynamic input, but a more constrained output. The dynamic input in the sense of natural language, and the output in the sense of, well, again, natural language, but gone narrowed down through a process that is defined in the GPT. And then also another big reason why you want to use a GPT is if any of the existing tools are of any use to you, then you can just click a checkbox and your GPT, your LLM can decide to use it. When not to use. So if you do not want to do, if you don't want to spend like 10 minutes configuring the GPT to do what you want, then it's probably not a great use of it. You might as well just go into a new chat and just start start resolving whatever you wanna do. And also, when not to use is if you have a multi-step process with several states, and in this case, I'm referring particularly to a GPT, not a assistance API, because you can configure an assistance API to have multiple steps. But in with regards to a GPT, how you would instruct it to like follow some kind of pipeline is through an instruction which is fallible. So for multi-steps, you probably want to use an assistance API or create your own LLM agent. So public GPTs that I gravitate to, sorry, I'm kind of like standing on my soapbox here, but are basically just whenever I don't want to put the public GPTs that I like to use from the GPT store are GPTs that just have an instruction that I just want to leverage. Like these guys probably already spent the 10 minutes crafting the prompt and the instruction, so I'm just gonna leverage what they did. Those are the public GPTs that I gravitate to, but frankly, I don't use public GPTs too often. So I primarily use them for personal use. And as I take as I figure for my personal use case, and this is like a common thing with LLMs, is that it kind of empowers anyone to have their own like assistant to do exactly and precisely what you want. So I find that by the time I find the GPT that I want, I probably could have already created my own using the GPT system. And also making your own is more predictable as you have access to like all of the configuration. So that's I'm gonna get off my soapbox and get into like more practical, like informative aspects of it. So a use case that I've used a GPT for that saved me a ridiculous amount of time was creating this assistance API dev assistant, and I'm gonna demo it here. Okay, so this is an assistant that I created to help build the assistance API. So this is kind of meta. I'm using the the GPTs platform to help me build the assistance API, quote unquote, like GPT, in parentheses GPTs, right? And it has access to, and it has three important components. Knowledge where I provided the documentation that OpenAI provides that includes how the GPTs are structured. So, and this is a, and I'll show you guys this file once we get to I think it's architecture. Actually, no, I never ended up showing this up. All right, let's show it right now. OpenAI Python client open API, something like that. The official OpenAI Python client. The official Python library for OpenAI. Yeah, okay, so here it is. No, this is the wrong thing. This is the client. If anybody, yikes, could you help me out here? Could you find the OpenAI Open API? Actually, this is it. Open API. Okay, right here. So this is a file that contains the exact structure of their API, and it's a pretty big file. Like, let's see how many lines of code we're talking. How many lines we're talking about? 13,000 lines. So you obviously, well, I guess if you're dealing with million token context windows, you could theoretically throw this in there, but then you're losing observability and you're just leaving it up to the LLM to figure out how to use it, right? So this is the file that I'm giving it access through knowledge, right? And then we have the code interpreter tool, and this I've instructed. I'll get into the details in a moment, but yeah, the code interpreter tool provides a programmatic means to access the previously provided knowledge file in a consistent manner and in an observable manner too. And then an instruction that orchestrates the process that I want to be that I want the GPT to be following. So this is a small diagram to illustrate how it works. So you have the user, and the user asks for the user asks for something like create post assistance endpoint, and that you got to figure out yourself. So that there's a little bit of work there, but once you figured out the endpoint that you want to recreate, you just throw that into the GPT, and then code interpreter takes over and requests and navigates through the OpenAPI specification to retrieve only the relevant information. And that is instructed by the instruction. All of these steps are basically this diagram here. You convert this into text, and that's what this instruction is. So it goes from code interpreter, it extracts the relevant information, it plans out the implementation by first creating a test, and then it communicates that to a user, asks for verification, keeping the human in the loop, right? It adds for authentication or verification from the user approves, and then it generates the code. And approves and maybe adds some extra details, and then it generates code. And at the same time, I also provide a reference file that shows some code snippets that I've already built so that it maintains my same coding pattern and style. And then over time, as the chat, as the conversation grows, it actually performs better, as many of the mistakes that it made throughout this process are inside of the conversation context, so that it likely won't make them again in the future. So it actually gets better over time. So that is the assistance. That is a diagram for the assistance API, and here I'm just gonna showcase what that looks like. So this is the GPT, and let's go into editor mode. Here's basically the steps that I tell it to follow, and yeah, this is an instruction I already ran through. Here are the code. Here are the files that I passed in, and then let's see an action. So here it is accessing the OpenAI API file. It is getting to the specific endpoint that I'm concerned about. It is extracting that information, and sometimes it includes references. So I've also added some code in here to handle references. Not code, added an instruction here to handle references. And then once that is analyzed, it is able to understand. Oh yeah, here it's handling the references. And this is the extracted reference. And here it's basically combining all of that knowledge and outputting like communicating what it knows about the endpoint. And then here, I think, yeah, here it proceeds on to the next steps. I tell it to create a test, and then it creates a test, and then I test it against the actual OpenAI hosted assistance API. If that works, then we just carry on and it creates the code. So this is something that saved me like a significant amount of time when building the assistance API. Is there any questions? Okay. All right, so I'll move on to the next segment. Oh, and if we have time later, and if you guys are interested, we can cross-examine if you guys don't trust that it's actually like doing the right work.
Kellen's asking if it's public, which I believe
Yep.
means like, is it open source? And I think the answer is
Yep.
yes, right?
Yes. I posted
I'll drop the
that.
repo actually.
Yeah, I dropped it in. Oh, the GPT itself, I don't think. Yeah, it's actually in the repo. It's here. Well, OpenGPTs-platform. And if we go towards the assistance API, I think I put it somewhere in here. Assistance API, run executor, nope. Right here. Yeah, so if you go to the repository for the assistance API, you can reach the GPT and try it and play around with it yourself. Yeah, so okay, so moving forward, well, what just happened? So moving forward, we're gonna cover the architecture, and to begin, I'm just gonna run through what the assistance API, um, looks like. Yeah, I'm just gonna do a quick run through of the assistance API running all locally on my machine. So for that, we're gonna move over here. I've already started the services that I need to get this running, and we'll discuss all of that in a moment. But for now, let's just focus on the actual assistance API. So for the assistance API, normally you wouldn't include this base URL, but because we're running it locally, we're routing all of the requests to localhost 8000. So we're gonna run that. And then we're gonna perform this custom tool to basically just clear out. So I don't want to get too deep into web retrieval, but what web retrieval is it crawls through websites, downloads all of the website's information, stores it in a vector database, and allows you to query that website via semantic search. So that's what web retrieval is about, and here I'm just clearing it so that we don't there's no prior knowledge in there. Okay, so next we're gonna create an assistant where I've just and to not get into like actually reading everything that's happening here. The goal of this GPT/assistant is to be able to provide give me a news feed that is relevant to myself, right? And myself being like in someone who's interested in space, somebody who's worked with like satellites, and I'll get into that in a moment. So yeah, this is a news provider basically, and we're gonna ask it to just without any tools, without anything, we're just gonna ask it to show me interesting space themed news from Y Combinator, and notice how there's no way you can know any of the relevant information. So I was just gonna say, you can find interesting, and I'll zoom in here. You can find get rid of that. You can find interesting space themed news from Y Combinator by visiting the website. So it's basically telling us nothing. So we can begin by adding the web retrieval tool. And we're going to add the web retrieval tool, and then we're going to start crawling Y Combinator or Hacker News. And as you can see, there's two things that we're trying to like access here. One is either this like new ways to catch gravitational waves, or this other spacey type article here, that the largest asteroid to pass between Earth and the moon. Wait, sorry. Discovered on June 16th, large asteroid to pass between Earth and Moon on Saturday, which is tomorrow. It's kind of interesting. So those are the things that we're trying to look for. And And in fact, while I was creating this presentation and I was running this before, I actually didn't know that. I didn't like check Y Combinator, and I was just informed of that through this GPT. So okay, now it crawled 40 sites, and we're gonna ask it the same question. Show me interesting space themed news from Y Combinator. And now that it has the web retrieval, it should have a better chance of giving me relevant information that I might be interested in. And this might take a moment. There's still a lot that needs to be optimized, particularly in the run execution, but we will get to that later as well. So the maximum amount of like action and thought exchanges it can have is 8. So I think it in this case it might have reached the limit. I'm not sure. But okay, so in this case it tells us sorry I couldn't receive any space themed information. Okay, not terribly useful yet. But now we introduce file search, which is something that is supported by OpenAI, by both OpenAI and OpenGPTs, and we're gonna pass it information from this file, which includes like some fictional information about somebody who has had a career in like this building satellites. So we're gonna pass it that information. I think I updated the instruction here, yeah, to access my files. So there is a slight modification here, and then we're gonna run well, actually a different query. Find me interesting news. I'm not even specifying space themed at this point. And now it might, again, this is a non-deterministic system, so hopefully we get lucky and we get it on the first try. Otherwise, I'll run it again and just continue with the presentation. Hopefully something good turns out of it. Okay. The latest news includes developments in space technology such as space mining, satellite constellations. Okay, asteroid. Is this what we wanted? Perfect. Yeah, so this is a showcase of an assistance API. This is the general flow that it follows. You give it access to Sorry, where was I? You give it access to tools. Well, you create an assistant. You give it access to the right tools. You create a thread. Then you create a run. Then you execute the run, and then you retrieve the messages from it. And then, well, that's the end of the process. And provided the right tools, it can accomplish nearly anything for all we're concerned here. So how does it all work? What is the architecture of it? Here's a high level demonstration of the architecture, which we'll take it step by step, but just to run through it at a high level, we have a graphical user interface client. You can think of this as like the actual OpenAI GPTs client, or you could use this everything that follows. You can connect it to something like LibreChat or Hugging Face or any other UI that is using the standard OpenAPI, OpenAI standard for assistance requests, right? And then and the reason for that is because the next step in the process and all of the requests that it's going to be making is going to be using the OpenAI client, and that is a requirement in order to make the system work. And then the client is going to make requests to the assistance API, and then that assistance API is going to be leveraging a range of services from Postgres, RabbitMQ, a database, a message broker, a file store, and a vector store. And then the run executor, when it is available again, it can dequeue and it can run the generation, run the agentic multi-step generation to give you the best response. And how it gets you that response is through accessing the large language model, either from open source that can be sourced through Olama, and it can be fed into an Light LM proxy that configures its outputs to align with the OpenAI standard for chat completions. And in the same way, you can just access the general inference providers hosted inference providers like Hugging Face, OpenAI, and others. So the GUI client, it's so the GUI client, it has an intuitive shape and structure that serves the configure that serves to give you like this seamless experience of creating a GPT and using the GPT. Um, it is limited in use probably from that same structure, but it is very easy to understand and get running with it. And it is also designed for fast iteration by having the the editing portion and the like actual playground side by side. So then we have the client SDK, which we'll be getting into more detail later, but um, it abstracts away the complexity of interfacing with the API through interrelated classes, and it also lends itself more towards an IDE, which by providing auto completion, so that whenever you're creating for example, if you go into vector stores, you press. And in fact, we can just do this live. If you go here and you don't remember like what methods you have available, what is supported by the API for threads, you can just do this, and then it can show you all of the different methods that you got to work with. So by having this like ORM system and SDK, it just makes the development process a lot simpler, a lot more streamlined, and it just communicates things much easier than having to cross-reference with some documentation, right? So that is the OpenAI client SDK. We'll get more into that in a moment. So the assistant API. This is, and notice the difference. I'm talking about the assistant like space API, not the not the entire system, not the entire system like as in here. We're talking about just the API. So the API manages business logic, performs operations against the services that were showcased here, and it also maintains a consistent state via to the database, and then dot dot dot. Now I'm going to be covering these things in a moment, but it enqueues runs to be executed, and that is basically its end state. Once it actually executes it, once it enqueues a run, that is basically the end of its flow, with regards to the flow that I discussed earlier for the assistance API. And then it also creates the associations between the different primitives in the different primitives in the, what do you call it, like the different tables, the different tables that you're working with whenever you're creating a GPT or assistant. And then it also stores files in file storage. It preprocesses and stores text in the vector database so that you can use for semantic retrieval. And it handles and the assistance API is capable of handling 100% of GPT's features. And what this link is referring to is a comparison between GPTs and assistants. And I think I should have probably included this a little earlier, but you can look at the differences here, and they're basically very similar, with the difference of the user interface and some important details here in the tools, where the GPT as deployed by OpenAI is contains two tools that are not available in the assistance API, which is browsing and DALL-E. Then you have code and interpreter and retrieval, which are supported by both. And then you have custom actions, which aren't necessarily, not directly supported by the assistance API. But through function calling, you can basically recreate custom actions. And actions is a thing I actually didn't talk about, and actions are super important. They're basically what enables ChatGPT to interact with an API, which basically just opens Pandora's box for what an LLM can do. So, yeah, going back 95%, and that 5% is referring to that function calling and actions. disassociation, or the difference between the two. And here's just like an equation, I guess. Assistance API plus actions achieves feature parity with GPTs minus, well, with GPTs minus UI. There we go. There's the finalized equation. Sorry. Okay. This never ended up happening. All right. So, what are the primitives? What are the core tables that consists of a assistant of the assistance API? We have the core assistant, the core assistants. Um, then we have threads, and I'm just gonna go top left to bottom right because the associations are not as predictable as they're not very intuitive. So you have the assistants, and they're its own thing. Then you have threads, which is oh, okay, and then you have threads. I thought you could do high fives. Whatever. You have the assistants, then you have threads, um, and those two are not actually related to each other. And then from threads, that's when things start getting connected. From threads, you have messages. You can have several messages, and from threads, you can have several runs. And you can only get the runs from threads. You can only get the messages from threads as well. Um, and for in the case of runs, you need both assistants and threads to get the runs. And then to get the run steps, and I think this portion is actually wrong. Feel free to correct me, but yeah, this portion right here. Um, Runs and run steps. In order to get the run steps, you need the run. Um, and the run steps are basically a much more granular view of runs. Um, and what is a run? This is something I didn't actually prepare for, but if you're interested, we can get into it later. But yeah, runs are the run object is just telling you like the current state of a run. So, and you can actually see this here in the run flow. Yeah, so you can see it here in the run flow. Um, the run flow begins in a queued state, which is when it's in like the message broker, and then it moves into in progress, and it can go into required action, which is sort of a tangent that I don't want to get into at the moment. Actually, I will get into it. Yep, I will get into it. Okay, so requires action. This is related to function calling, and and it is important. It is very well. It is critical in order to mimic actions, but I'll get to that in a moment. And then it can get canceled whenever you stop a generation. That's what happens. You end up canceling an in progress or potentially queued run. And eventually, and most of the time, what the flow that it's gonna go through is queued in progress completed. If you have functions, then it's gonna be queued in progress requires action, queued in progress requires that just loops over and over for as many functions as you need, and then eventually it'll eventually get to completed. So what does it take to get from function calling to an action? So to do that, you need to first transform an OpenAPI specification, and for this, I think some prior knowledge is important. And we're gonna run into another GPT that I've created. Digibook. This is play on Facebook just for digital twins. And this one does use actions. So this is currently being hosted on this URL, and here is the OpenAPI specification. So you wanted to, in order to operate with function calling, you need to use function signatures, which takes a different format than the OpenAPI specification. So you want to transform this OpenAPI specification into function calling. Hopefully it shows up here. Into something that looks like this. Into this, which is what is called a function signature. So you want to transform an API into that. So um, so yeah, that is step number one. Then at the same time, you need to create you use the same open API to create a dynamic HTTP querying function. What that means is you create a function that can take the inputs of the OpenAI. If it's a function that knows how to use the function the function signatures that you provided to it to then actually query the website that you're trying to get information from. So this is the function that actually performs the query to that website, and then once you've already retrieved that information, you you basically you give it that information back into requires action, and then it transitions back to queued, where it just where from which point you've completed the function calling. You've completed the action flow basically. Once these three steps are done, and you've provided the once you've provided the outputs of the query to the API, you have now imitated actions via function calling. And that's how LibreChat does it, and that's how Open Plugin used to work. Yeah, so that is actions. And is there any questions so far? I see somebody's typing, so I'm gonna give you like a couple more seconds. I don't know if it's specifically public, but there are repos out there people who have extracted the prompt's knowledge from custom GPTs. Oh, interesting.
Yeah, there's several of those, which might be
Yeah.
um a
Yeah,
good
so
part of the export feature.
yeah, from the plugin store when that existed, um that was actually like publicly available. You could publicly access the APIs in the manifest files. I didn't know you could do that with GPT, so that is interesting. I'll take a look at that. I'll throw this over to somewhere else.
I think most of them are like jailbreaking or prompt injection, so they're not like the full code, but they're the stuff you would need to make the GPT at least.
Mm. Yeah. Okay. Apparently, it wasn't directed to me, but cool. Nice to learn, anyways. Okay. So next, the run executor, and um, I don't think I want to actually get into the papers, but where are we? 43. Okay, yeah, we definitely are not getting into the papers, but the run executor. The high level of how the run executor works is designed after the Cognitive Architectures for Language Agents paper, which is building upon the work of React and I'm sure other papers. So the high level design is basically they introduce different kinds of memory. They introduce long term memory, episodic memory, and semantic memory. And you can create parallels between their classifications of memory and the and what's actually like the assistance API. Where the long term memory is equivalent to a conversation where you can have like multiple back and forths, right? And then the episodic memory is the run. Yeah, the run which can have like multiple uses of tools over the course of a single run, and then the semantic memory is observations. It's just like a single exchange um between like a single action. Like the LLM performs an action and it returns an observation. And this is sort of diagram here. Like, yeah, so the semantic memory is kind of represented here by observations and actions. And if you just continue this cycle until a run is complete, then that is the episodic memory. And over the course of a conversation, you have the long-term memory. Okay, so low level, and again, this is like the more atomic portion of the cognitive agents architecture paper anyways. Um, at a lower level, it works. All right, this is a tangent. It's basically just a simple flow between reasoning and acting, where the LLM thinks through what it should perform, and then it um, and then it performs an action, tool use, right? So it builds the episodic memory, so it builds the run, right? And here's the LangChain prompt that it can get you up and running with React, and it illustrates how it works. So first, you begin with the original question, the prompt of the user, and in the case of the run executor, um, in the case of the run, damn, what did I call it? Run executor. Run executor worker is what I actually call it in the repo. So run executor, in the case of run executor worker, the question is actually not the exact prompt that the user sent, but it is a rephrase. It is rephrased. Um, it is rephrased to provide a more because you need to know what. Oh, sorry. um, Whenever you're executing a run, you don't just want to give it the last prompt, right? You need to know the context of the whole conversation, right? But the last prompt is disproportionately more important than the rest of the conversation. And you can ideally just pass in the entire text dump of the entire conversation, but then that's gonna be a large cost in regards of token inputs and generation. Well, actually, just token inputs, just large amount of token inputs. So to reduce that, you can rephrase it and have it give you a more concise, just kind of like a summarized version of the question that the user is asking with all the context included. So that's how OpenGPTs handles it. Then what happens from there is the LLM thinks about what it should do. Then it performs an action according to a list of tools, which are defined by what the list of tools that we defined in the assistance API. And then the action input. Yeah, so the action input, which is on a tool by tool basis, and then the output of the action, which can be the OpenGPTs-platform just handles as basically a text dump of whatever. It doesn't have a particular type, is what I'm trying to get at. It just returns whatever it observed in text, in text in the modality of text. And then this continues over and over and over again until it reaches a final answer, which is the terminal state. Yeah, this is just like a one shot. Yeah, there's a one shot example. You can think of it that way, and then here is where it actually begins the generation. And notice how this React is designed to work with a base LLM model, not a instruction tool model. So that is like one of the bigger inconveniences with using React for an LLM. Sorry, for OpenGPTs. Okay. Yeah, so that is run executor worker, and then there are some improvements that can be made. Number one is, yeah, as I mentioned, React through instruction tuned LLM. If we can get that to work through some manner, it would make things a lot better. Another thing we can do is structure the inputs and outputs of I never finished this, of the whole process. Just there's several steps in process. There's several steps, and in fact, you can actually find those. Notice how the file that I linked, in case you were lost, contains basically all of the documentation, all the visual documentation for OpenGPTs, or well, at least the public one. And somewhere in here, I've actually illustrated the process of how the run execution happens. So this here is how the run executor works, and there's a lot of these steps. Each one of these purple steps are an LLM generation, and the outputs are not very structured. And so if I can just tap into LangChain, which is I originally formerly was a LangChain hater, but I kind of see the use now. If I can just get structured inputs and outputs out of these things, life is good. So that is one of the other big improvements, just transitioning over to LangChain without being entirely dependent on them. So yeah, that is the architecture of OpenGPTs, or the architecture of GPTs. And then we can get into the client, but we're already running a little short for time, so I don't know if I really want to get into it. Um, but I'll do like a quick preview. I'll do a quick preview, yeah. So for those of you who don't know, I'll do a quick trivia. Actually, before then, any questions? Any questions? All right, I'll move on. So I'm just gonna get through these 3 slides, and potentially I'll do another presentation in the future to get more into this. And frankly, I didn't even finish the presentation as I promised. So I'll just get through these 3 as to serve as a teaser or what I could potentially cover in the future. So, question: who would you imagine is the top contributor to? For those of you who don't know, who is the top contributor of the magnificent OpenAI client? Who do you guys suspect would be the guy behind this OpenAI Python client?
I have no idea.
Just take a guess. Anything. What are the qualities in this person?
See, Python. I don't even know who's working. Who would be working at OpenAI to name
Yeah,
anyone?
well, yeah. One of the top contributors is working at OpenAI. I'll tell you that much, but not the top one.
Oh, interesting. Not the top one.
Indeed. So, any guesses?
Um, is it I don't know, you were just talking about LangChain. Is it Harrison?
That'll be. Well, I don't see the overlap, but interesting. Yeah.
Yeah. I'm
Because
just taking random guesses.
yeah, yeah. I, yeah, Harrison, he like builds a great package, but it's not necessarily an SDK. It's not an SDK client. All right, so to do the big reveal, who is the top contributor? Let's look at the contributors. It's a bot,
Nice.
and it completely dwarfs everybody else. And um, just to like showcase this better, pre version 1.0, Mr. Hallisey was the top contributor doing an honest day's work developing this SDK. And with Rachel Lim coming in second place. And it was nice. I don't know who used the client before version 1.1, but it worked. It was kind of it was limited. You knew the endpoints, and they didn't really have any relation with other endpoints, and that's how you used it. And then enter version 1.1. You get basically Stainless Bot just taking over the entire project. And then there is somebody notable here, which is Mr. Robert the Craggle Craggy. And there's a relation between these two. Robert Craigie is the founder of Stainless. Um, and so he was basically, I would imagining at this point, he was just like um, scouting the repository, learning how it worked. And then eventually, and this is just a hypothesis. Well, actually, I don't know what happened, but he's the founder of Stainless. He was evaluating, and I'm assuming he was evaluating the OpenAI client, and then eventually he released the Stainless bot onto OpenAI. Probably did a partnership with OpenAI, and ever since the OpenAI client, and this one, much like the OpenAI JavaScript client, they're both created by Stainless. Um, Yeah, so here you can see the top contributor again, stainless bot. Yeah, so who's the top contributor, pre, post, and then we have Robert the Craggle Craigie. And why I added the Craggle there is just for those of you unfamiliar with the Lego movie, the Craggle is kind of the like antagonist's weapon to like keep things in place, keep Legos in place so that you can't ever like change them. This limits creativity, right? Well, I would say in the case of software, I think this is good. So, um, ideally, if your code never gets refactored, um, then you're doing a good job. So Robert Craig, that's Robert Craigie, and then there's a lot of different aspects to cover in stainless, but that's where I'm gonna end the talk. And yeah, so are there any questions, any comments? Thank you, thank you. That would be cool. I'm gonna be here until everybody stops typing, and then I'm gonna probably take a nap. um, what do you mean by lightning talks, Nuvik? Awesome. Yeah. Feel free. There's a Discord on the OpenGPT GitHub. You're welcome to join that, and I'm always happy to help you out if anything happens. What does Nuvik mean by lightning talks? Yeah, yeah, I couldn't hear you.
Yeah, I think a recap would be great. Sorry, I was just AFK for just a second. Yeah, AI Engineer Conference would be recap would be dope. That sounds like a plan to me. Well, I'm sure we'll have to coordinate with some folks that were um, in attendance, but yeah. Thank you, Mr. Sebastian. That was
No
dope.
problem.
It's clear that you put a lot of effort into it. I think Boo
More
was
than before.
asking, is there do you have slides or anything that you can drop off outside of just the
Yeah, I posted
repos
them
or anything?
on AI in Action, both the repo and the Figma, and
Sweet,
the Figma contains the fig slides.
sweet. Yeah, well, it's super impressive work. I know we hacked on it a little bit, but you trucked through and made it happen. So nice work, man.
Yeah, thanks, thanks. Yeah, if anybody is interested in contributing, feel free to drop into that Discord. I'm more than happy to help you guys contribute. Would love to see. In particular, there's something that I wanted to touch on, which was expanding and being able to add tools. If you guys have any tools that you think would be cool, would be a good fit for a GPT. And one of the big ones that we're like currently discussing with the Yikes and some other people is getting Devin integrated into GPTs
Mhm.
as a replacement for code interpreter. And that basically anything goes. If you have any idea for a tool that an LLM could talk to, hit me up.
Yeah, the open sourciness will make it a way cooler thing than what the GPT store has, I think. So yeah, it should be cool
Yeah.
to kind of watch it grow out. So yeah, go check it out.
All
And
right.
with that, I guess we will wrap it up right on time. But yeah, I'll send you the. Do you or did you end up recording, Seb? Are you good? Or
Yeah,
do
I
you want me to send it
recorded.
over?